You're supposed to do division to get rid of it, right? But the reason it also always worked it's this way, because see, like the last example we had here, we had multiplication, so we divide both sides by 2, because the inverse operation to reverse multiplication, we do division. And for, most of the questions worked, like this one. See, we divide by 7, right? It worked. But the problem, even this one with decimals, it's multiplication, so we divide the number in front of it, and that works. The problem with fraction, this procedure always works, okay? So Bailey said we can divide. Yes, actually it will work, but division will look a little scary. So let me write it for you, and you will see what I mean by scary. Because you always have to divide the number in front of it. When you have 2, if I give you 2x equals 6, multiplication between them, so you divide both sides by 2. Okay, you get rid of 2 immediately, right? But even if it's a decimal, it's still not too bad. You can look at example 8. But when you have a fraction, what you need to divide is that fraction. So let me write it for you. It just looks like a fraction in fraction, okay? So you will have 2/5 divided by 2/5, and then you have 16 divided by 2/5. And I don't know if you guys have learned this. We have a name for this. It's called a complex fraction. And why we call it complex fraction, you can see it. It just looks very complex, right? Okay, so this will work. So the way we do this is, instead of using this horizontal line for division, we know we have other symbols for division. In this division, we also have that symbol, right? So this symbol will make it look very scary. So very complicated. So the other way, most of the time we use the symbol because it's easy to write. Just put it right under it, right below it, right? But for this case, we actually probably should use the other symbol because it will not look too bad to do. Okay, so when I use this division symbol, we already learned this. Okay, if you look at your homework too, that I graded, and I ask you to do questions like that. Okay, so remember, how do we divide fractions? What's the rule? What's the rule for dividing fractions? Does anybody remember? I'll give you a quick tip.
Keep, change, flip.
Yes, thank you. Very good. So you will keep this first one and change division to multiplication and flip it. There's one student, I forgot who, in the homework grading, and somehow also change the first fraction. Make sure you don't, well, oh, I'm sorry, that's what I meant. Actually, use this rule for multiplication. So this only works for division, not multiplication. Multiplication, you just go ahead and multiply straight across. So let's say if you have 1/4 times 2/5, you don't need to do keep, change, flip. Okay, that's for division. For division, yes, you do have to flip. For multiplication, you don't flip. You don't need to flip this one. You just 1 times 2, 4 times 5. Okay, so whoever did that in the homework, make sure you remember, keep, change, flip is only for division. So we can do the same thing for the right hand side. 16 times, so we keep, change, flip. Okay, so we change all of them to multiplication now, because that's the rule for dividing fractions. And then we're going to multiply. By the way, it's all multiplication. See, multiplication, right? So multiplication, what's the rule? Straight across. X, it doesn't look like a fraction. I can put a 1 underneath. So now you can look straight across. Top times top, see, top times top times top, straight across. And bottom times bottom times bottom. And similarly, I can put a 1 underneath 16. So you would do straight across, top times top, bottom times bottom. So the top, you will see that you don't really have to multiply them. I'm just going to copy all the numbers. The reason I didn't multiply them out, it's because you can reduce a lot of numbers. See, look, this 2 reduce that 2. This 5 reduce that 5, cancel that 5. So you get rid of all the numbers. You're left with the x. We are left with the x over 1, but any number x divided by 1 is still x. So I got rid of that 1. On the right-hand side, I can still do the same thing. 2 cancels 16, which is 8. And 2 goes in 16 8 times, and multiply 8 and 5, which is 40. So that would be the final answer. Okay, so what we did is we still follow the normal procedure, If there's multiplication, we divide, but don't use the horizontal line, the fraction symbol, and use the other division symbol. And then you'll be able to use keep, change, flip. Use keep, change, flip to do that, to deal with the fractions. So this part right here, that is something we did in homework 2. Okay, so we practiced some of the multiplication, division of fractions with the variables in there. Okay, but I want you to take a look at the solution. I told you there's another solution. So this is usually not what we do. So is there any quick way to do it? Yes, there is. I want you to take a look at this step right here we did. After we apply the rule keep, change, flip, we end up with, if you look, what did we end up with? I'm going to rewrite this. 2/5 x times 5/2 equals 16 times 5/2. See, what I did here, I just copied that one more time using 2 different colors. 2/5, see, this is 2/5 x. We kept it that in blue. And that is the one after we do keep, change, flip. We got times 2/5 times 2/5. So if you remember this tip, even if you use division, you're still going to use keep, change, flip to get rid of division, to convert that to a multiplication. So this is why when you have a fraction, you want to get rid of fraction, you could, you could just multiply what we call reciprocal. Okay, if you remember the name. So when we do this type of question, and instead of dividing both sides by 2/5, you could choose to multiply both sides by 5/2. What is 5/2? We call it reciprocal of 2/5. What is a reciprocal? It's flipping the top and the bottom. And why? Because of the process we did. So if you remember this tip, say, okay, now I need to divide both sides by 2/5 to get rid of 2/5, right? Well, because of keep, change, flip, somehow you're still gonna get a multiplication. And why don't we just skip? So you could skip this whole process, skip that. Just go ahead and go to the multiplication step. Okay, so this is something we kind of have to remember that. And it makes sense though. Why? Why don't we do division? First of all, because division can be converted to multiplication. Secondly, if you look at the multiplication here, look at this multiplication. 2 cancels 2, 5 cancels 5. All of, 2 is gone, 5 is gone, so you don't have the fraction 2/5 there anymore, right? So because whenever you multiply, see, here's something that I want to show you. We did talk about this in section 1.5. You may have not remembered the name. We call it a multiplicative inverse, also called a reciprocal. Whenever you have 2 fractions, you flip top and bottom, and you try to multiply them, you always end up with 1. Why? Because top 3 cancels bottom 3. Because the top 3 was flipped to the bottom, and the bottom 2 cancels the top 2 because the bottom 2 was flipped to the top, right? So that's why when you have fraction you need to get rid of, instead of dividing, we actually choose to multiply what we call a reciprocal. Okay, any questions? So we multiply both sides by the reciprocal, which is flip this number and you multiply. So you multiply by 5/2 because that 2 cancels 2, 5 cancels 5, you simply get an x, and then you can reduce that to get a 40. So this is the way we do when you have fractions. Okay, I want to give you another example here. So let's go ahead and look at this one. Okay, of course it has 2 ways. Okay, one is to divide by this fraction, but it's going to be a little harder. So let's choose to use multiplication. So what do we multiply in order to get rid of this 2/3 here? By what number?
Multiply both sides by 3/2.
Yes, 3/2. Cami, I think I don't know if you flip it. You had what you had is 2/3, right? So we got to flip 2/3 to get a 3/2. Okay, because if you multiply the same number, 2/3 and 2/3, you're not gonna be able to cancel them, right? So these two both on the top, you have to multiply them and multiply them. You're not gonna be able to get rid of it. So so what we like to do is to flip that 2/3 to a 3/2. So now you can get rid of that. So I'm gonna show you here. So you're gonna multiply 3/2 here and 3/2 here. It doesn't matter where you put it. Yes, usually you should put it right behind it, right? But it doesn't matter. If you remember, we talked about the property of multiplication is commutative, right? So you can move it anywhere you want. So now when you look at it, so look, 3 cancels 3, 2 cancels 2. It's all gone, okay? And then you just end up with the x. And the right-hand side multiplies straight across, 21/10, okay? Nothing to reduce, I already checked, okay? So questions?
Yeah, we can only use that multiplication way if it's equals a fraction as well, right? You can't use that on a whole number.
Yes, you can.
Okay.
You mean, wait, hold on. What do you mean? You mean which side is whole number? The right-hand side or the left?
Yeah, if the right-hand side was a whole and then the left was a fraction, you probably wouldn't use that.
Yes, you will. Like the one, remember example 7? See, the right-hand side is whole number, right? So it will still work. See, the only time you won't use this is if you're trying to get rid of a whole number. Say if I have 2x, well, actually, you might still want to use it, okay? So if you want to divide by 2, it still doesn't look very easy, right? So you can, well, you can divide by 2 both sides, and you still got to use keep change flip to do it because there's a fraction involved. So usually, when do you not use it? It's probably like when you have whole numbers on both sides like this. Say, okay, well, get rid of 2. I can divide both sides by 2 to get answer immediately, right? Once you have a fraction involved, it doesn't matter whether the other side is a fraction or not. We still use it. So say I have, equals 16, because you still want to get rid of this number. So you want to multiply by 3/2 because that would get rid of this 3 and 2 immediately. So the other side, whatever that is, right? So we just whole number, fraction, it really doesn't matter. So we still work it out, right? Okay. Yeah, that's a good question because sometimes, see, the thing is when you have 2 different ways to do the problem, you may be wondering, okay, when should I use this way, right? This method. So the tip is whenever you have multiplying a fraction somehow involved, this is usually better, okay? The other way still works. So I'm going to show you the other way just for fun maybe. But of course, I don't expect you to do that. And personally, I would never do this way. So you could take this, divide both sides by 2/3, divide by the same number. But then what you have to do next, in order to do that division, you still have to do keep change flip. You still end up with exactly the same thing, see? And you had an extra step right there, right? So that's why we actually just give you this shortcut. Just go ahead and multiply the reciprocal, okay? This is called the reciprocal. Questions? Okay, so there's one last example for today is this one here. 1/2 x equals 7. So you want to get rid of 1/2. What can we do? Multiply by 2/1, yes. Okay, so you can multiply by 2/1 or multiply by 2. So in this case, because you want to get rid of this 2 on the bottom, right? So we could take this multiply by 2/1 both sides, and that because this 2 cancels that 2, and now you just end up with the x equals 14. Okay, and also this way also works for like if you have 2x equals 3/5. Say, because division, you can divide both sides by 2, but it's still going to give you a complex fraction. You still have to probably use the other division symbol. So when you do that, you can also use the same thing. Because this 2 you can treat it as a fraction. It may look like, okay, it's a whole number. Why can't we use this way? Because you can treat 2 as 2/1. So what do we multiply to get rid of that 2? Can you see what we should multiply to get rid of this 2 here? Yes, 1/2. Okay, so you still flip 2/1 and you get 1/2. So you will have, cancel this, so you get 3/10. Okay. All right, so after some practice, you probably will understand. So my tip for you is, when do we use this method? Multiply by reciprocal if you have a fraction involved, and also it's multiplication. Okay, so if it's subtraction or addition, you don't, because like this one, we do have a bunch of fractions, but it's, it's subtraction. We're supposed to do addition, okay, not division. For division, we have keep, change, flip, but for addition, you just do addition. There's no keep, change, flip to change it. Okay. All right, so that's all for today. I have 3 bonus questions for you.